Hello, welcome to this video from OMG Revision. In this video we're going to be looking at the GCSE Geography Paper 3 Fieldwork write-up. Okay, so these are the very last GCSE questions you will answer because they come right at the end of Paper 3. Remember, Paper 3 is a little bit shorter than Papers 1 and 2. It is 1 hour 15 minutes and there are 76 marks available. Now, for your field work, which you can basically learn off by heart and insert the right answers when and where you need to, it is worth 23 marks. Okay, now bear in mind you only need roughly, it's less than 20 marks to get a grade 1. So we're talking some good marks here. Alright, now this is not going to be a video on how to answer these questions. We're going to talk through the field work and all the different elements of the field work. But just so you know, I've screenshotted some images here of typical exam paper questions, and it is question 5 in paper 3. So as you can see, if you follow my cursor, you're going to be asked to write the title of your fieldwork inquiry. This is about physical. Explain the advantages of the location. So we'll talk about that when I go through the fieldwork write-up in a little while. We're going to justify one of the data collection methods. That's a common question. Moving on to this question here. This one's asking you about your human geography fieldwork. And it's talking about assess how effective your presentation techniques are. So what kind of graphs and charts did you use and why? And finally, pretty common kind of question is you get to choose your inquiry and then discuss to what extent were results of this inquiry helpful in reaching a reliable conclusion. So we will teach you, okay, and we may well do a model answer video for you as well on what you can write in all these questions. So, Geography 3, I'm forgetting how to speak, Geography 3, GCSE Geography Paper 3 Fieldwork Write-Up. Alright, so we completed both of our human and physical fieldwork at Cardy Mill Valley in Shropshire. So you can see what the valley looks like here. We all clambered up this lovely V-shaped valley to the top of Lightspout Hollow. The waterfall was up there, and it was located here, so very close to Wales in the west of England. Now, our physical fieldwork involved a river study to test whether the river channel cross-profile changes downstream. So a cross-profile is a slice. So, for example, you could do a slice for a river here where my cursor is, and you were looking at the width and the depth of the river channel. Okay? Whereas our human fieldwork, and a lot of you forget that we did the human fieldwork on the same day, we did environmental surveys and we were measuring the impact of tourism. So we started at the visitor centre where you expect the impact to be higher. We did an environmental survey, and then we moved in 4 directions, north, east, south, west, at distances of 200 metres, because that was long enough to show a range and to show the impacts of tourism changing. Alright, now here we've got an OS map, or an Ordnance Survey map of Cardy Mill Valley. Now, we generally started our fieldwork here. You can see the symbol for the toilets, and this is where the visitor centre is. You'll also notice that there's lots of orange lines on this map. Now, orange lines are contour lines, and when they're as close together as they are in this map, it's showing the land is very steep. So when we were there having lunch, you would notice that either side of you, you had a really steep hill, and you were at the bottom of the valley. And what we did is we walked all the way up the valley. You will notice how some of these rounded orange lines link into each other. These were the interlocking spurs. We walked all the way up the valley, and then we went west up to Lightspout Hollow where the waterfall was, and that was where we started our physical inquiry. Alright, so first things first, before we do anything, risk assessment. Well, I'm moving my slides, move my picture a little bit. Right. Before you do any study, or before you do anything really, but especially important with geographical fieldwork inquiries, you need to do a risk assessment. Assess the risks. What could hurt you when you go there? A quite obvious one is when you're walking up a river valley, you should be wearing appropriate footwear, such as walking boots, because if you're not, you could twist your ankle and you could hurt yourself. Other things to consider are the weather. The UK weather is very changeable. In the summer, you would be very exposed to the sun. So have you got sunscreen to protect you from sunburn? If you want a lovely ghost-like complexion like me, I recommend Factor 50. But I tend to use baby sun cream because it's even stronger. So that's some risks. Other risks, more for the human one, are to do with vehicles. Now, one reason we chose Cardiff Mill Valley is because the speed limit has got a 5 mile per hour restriction, so vehicles move very slow through the valley. However, you still need to be sensible when crossing the road. So, using your green cross code, stop, look and listen before you cross the road. Other things to reduce risk is always make sure you are with somebody else. So, minimum 2 people in pairs. So if one of you should get hurt or injured, the other person can then get help. Okay, so these are all basic things that we do before we go to minimise the risk. Okay, it's called a risk assessment. Anyway, we're going to start off, whoa, let me move this. We're going to start off with the human fieldwork, and the reason being is this is the one people tend to forget. So we did the human fieldwork in the afternoon, and it's, does tourism have a negative impact on the environment of Cardiff Mill Valley? Okay, so did people going there damage the environment? So that was our question. That's what you would write where it says inquiry question in the exam. Our hypothesis, what do we expect? The environmental quality will improve as you move away from the visitor centre. Okay, so at the visitor centre we say the environment's going to be the noisiest, it's going to have the most litter, whereas as you move away, the environment should get better. Now, why have we chose this location? So, the reason we have chose this location is because the footpaths are well maintained by the National Trust. Okay? And this means that the risk is low because there's proper footpaths for you and I and all the students to walk on. So that's one reason we chose it. The another one, and this is what you could write in the exam, is there was a range of survey points in a safe environment that would allow enough variation within the locality to show change over distance. You could just learn that phrase, why we chose this location, off by heart if you wanted to. But ultimately what it's saying is there was enough space for us to do our inquiry. Okay, and there was enough distance between the visitor centre going north, 200, 400, 600 metres to show variation. Alright, other things you could mention, it was accessible by coach in under an hour, so it was relatively local. Relative geographical theory. So, this is secondary data that somebody else has collected. So, there's an ongoing debate. Every geography lesson is going to have some of this to an extent. The pre-release paper is going to be talking about this. There's an ongoing debate around economic development versus environmental sustainability. So is making money worth it for the impact it's going to have on the environment? And there was a guy called Butler, and he suggested that tourists can have a negative impact on the environment. So that's our secondary research. Now, methodology. Method, what you did. Alright? Like in a science experiment, what did you do? What was your method? So, first one was an environmental survey, and this is primary data, because we collect primary data. How was it done? So, we conducted environmental surveys that gave an area a score out of 10, with 0 being bad, 10 being good. And we gave them a score out of 10 for their noise. Was there any vandalism? Was there any litter? Was there evidence of human impact? And was there any unnatural smells? Bit of a tenuous one because there was a lot of sheep around. People might have thought that was unnatural. However, it's quite natural, sheep poo. So, why was it done? This is the reason that we did the method. So we're justifying why we chose this method. Now keep in the back of your head, you are 15, 16-year-old kids in a secondary school. Alright, we've not got a multi-million-pound budget to do this. So keep that in the back of your head. Now, it says, the The method was simple but effective, and it allowed us to test the quality of the environment at and around the visitor centre. The data that we got was easy to understand, and it should be accurate. The visitor centre is more likely to have a poor environment because more people are likely to congregate in this area. So our environmental surveys and the moving 200 metres away at a time is a perfect way for us to test the environment, isn't it? Sampling method and reason. So we use something called systematic sample. Think of the word system. We put a system in place. And ultimately, we measured the environment with our environmental surveys at 200 metre intervals, gaps in between. Alright? And we did this in 4 directions, north, east, south and west. And we did this to give us a fair distance to show environmental variation and also avoid any bias. Because we could have just gone to a place that looked dirty and said, man, it's horrible here. Alright? We had to have a system in place to get rid of that bias. And the link to the hypotheses, we wanted to use primary data, what we collected ourselves, to test whether the quality of the environment improves as you move away from the visitor centre. That's what we expected. The second method we did is we took photographs at each site. Alright? So, at each site, so at the visitor centre is site 1, 200 metres north, site 2, 400 metres north, site 3. At each site, we took photographs that we could use for interpretation in the classroom. We took photographs from different angles and of anything of particular interest. Why did we do this? Well, again, it was simple and easy to conduct because everybody, or almost everybody, has got a mobile phone and they have got cameras on the back, haven't they? All right, some pretty good cameras on mobile phones, digital cameras. Also, a photograph provides us with a large amount of information that we can interpret back in the classroom. All right, so a field sketch could have been used, but that's not going to show you anywhere near as much information as a photograph. What sampling method did we use and what was the reason? So again, we used systematic sampling because we did it at the 200 metre intervals, and it was easy and simple to conduct. And the photograph, all right, the reason we use the photograph to sample the environment is because it provides an accurate visualisation of each site, and we could interpret this back in the classroom. A photograph's not going to lie, is it? Links to hypotheses. Well, the photograph gave us a clear visualisation of the environment at each site. What does it look like, visual, so that we could assess the quality of the environment. All right, so we got our methods to collect our primary data, always keeping in the back of your head that we're trying to answer this question. That's the purpose of our investigation. So, once we've got our data, how are we going to present it? And like I showed you earlier in this video, there was a 6-mark question on this, so we need to be clued up on it. So, presentation methods, reasons for presentation methods. So what we did is we used located bar graphs and photographs to show the quality of the environment at each site. Okay? So bar graphs. Ultimately, all we did is we made our bar graphs that showed the data from the environmental survey. We got the base map, and then we put the bar graph on top. Simple as that. So there should have been 1 bar graph at the visitor centre, 3 bar graphs north, 3 east, 3 south, 3 west. So in total you should have had 3, 6, 9, 12, 13 bar graphs. Now the x-axis, which is along the bottom, showed the category of the environmental survey, such as human impact, noise or natural smells. And the y-axis going up the side showed the score out of 10 for each category. Now, we used a bar chart because it was the most appropriate. The data was not continuous. We'd have used a line graph, it was continuous. It was discrete. So what that means is each score for each element was separate. Now, the located bar graphs were visually clear and allowed us to spot patterns and anomalies at all the different sites that we completed an environmental surveyor. So we could very quickly look at our maps, we could look at the bar graphs, and we could quickly spot patterns and anomalies. For example, if for some reason 600 metres south the environment was really bad, we could very quickly see the bars are lower and identify that. Now, this is a statement you could learn. This was appropriate to a large extent, as the bar graphs gave us the environmental scores and they were supported by photographs, so we could easily visualise the quality of the environment at each site. If we'd have had more time, we could have even put the photographs next to the environmental survey to make the data presentation more complex and even better. Right, interpretation. So, an interpretation, if you had an interpreter between a French and an English person, they would just be telling you what the other person's saying in a different language. When we interpret data, we just explain what the data is showing. Alright? So, this is what I've written. The data showed that the environmental scores were lower at the visitor centre. However, they tended to improve as you increase the distance from the visitor centre. We use measures of central tendency, such as the mean, in order to find the average for each site and remove outliers and anomalies. Alright? So again, they will ask you questions about what methods of central tendency you used, or they might not. They might call it an average. That's ultimately what it is. Now, the mean is really good because if you add up all the scores and divide by the number of numbers, any extreme data that really doesn't fit the pattern should be removed. But there are other things you could use, like the mode. So, I don't know, maybe site 1 scored 5, 4, 5, 4, 5. Well, the most common score it got was 5. That's the most common. Alright? Could also do the range. But I don't know how much that would help us in this particular occasion. So, we use the mean. Conclusion. So, remember again, our conclusion is based upon the results. And the results are based on our methods. And all of this was done so we could answer our original aim. Does tourism have a negative impact on the environment at Cardiff Mill Valley? So here's our conclusion then. In conclusion, the quality of the environment was lower at the visitor centre and higher with increasing distance from the visitor centre. This conclusion is valid to some extent. However, it was based on results that used from people's opinions. We could say that the conclusions are not 100% reliable. Right, so I might have read that a little bit wrong, but ultimately, you need to get into your heads the following. The validity of the conclusions is based upon the accuracy of the results, and the accuracy of results is based on the reliability of the methods. Ultimately, what I'm saying here is, I think we can say our conclusions are valid. We can trust them. But we can't trust them 100% because there are some problems with the accuracy of the results. The problems were these results were based on a method that used people's opinions. And people's opinion of what's good and bad and what's loud and quiet may well be different. Alright? So, let's have a look at how we can evaluate this. I'm going to move my face. I'm going to put it over here by the methods because we're going to get the methods up here again, aren't we? So, method name, environmental survey. Reliability. How reliable, what problems? So I've wrote, the method was reliable. However, it was based on people's opinions and people have different opinions. One person's perception of a clean environment may be different to another person. So that's a problem. So we're talking about reliability. Then, impacts on accuracy of results. I've put, this method was reliable. However, it was based on people's opinions, meaning the results are subjective. Brilliant word. Subjective basically means subjective to what they believe. Alright, and as we know, humans' opinions are all different. Impact on validity of conclusions. So, I have written, this had an impact on the conclusions to some extent, as it was subjective and based on people's opinions, and they may be biased. So the idea of their opinion being correct is bias. Alright? Solutions? Well, you could have two people discuss the environmental scores to reduce this bias. So have two people complete it together and agree on the scores, or three people. Okay? Also checking to make sure they've done everything correct. Second thing, you could complete the environmental survey at a different time. So I've suggested at the weekend when the area may be busier, because at the weekend when people are not at work, there might be more people there, and this might change the impact on the environment. Or it might be different, there might be less people there because there's not kids on field trips. So those are two things. Do it with another person, double check. You could potentially repeat it again, repeat the experiment and check it, see what the data looks like. Or go at a different time of the week. You could even do a different time of the day. Taking photographs at each side. So, I have said reliability. This method was reliable. Photographs give much more information than a field sketch and give a good visual appreciation of the environment. Okay, so photographs, as I said, don't tell any lies, give you a really good impression of what the environment looks like. And this actually improved the accuracy of results, as it allowed us to verify the results from the environmental survey that were based on opinions that were subjective. So in a nutshell, what I'm saying is the photographs, we could get the photograph, and if someone said it scored really low for evidence of human activity, and there was, I don't know, a house built there, or a car, or a road, you could say, well, hang on, there is lots of evidence for human activity. Okay? How did this impact the validity of conclusions? So I've said it improved the validity of the conclusions because they improved the accuracy of our results that we based our conclusions on. I hope I'm not confusing you. All I'm saying is the validity of the conclusions was improved or increased because our results were more accurate, because the photographs made our methods more reliable. If we did want to improve further, we could take photographs on a different day, such as the weekend when it might be busier. Or you could take them at different times of the day. We did it in the afternoon. Could you take it in the morning? Or we could repeat the investigation again in a different season to compare our results. So we went in the summer. Would the results be different in the winter or the autumn? Okay? So these are the things we could do to improve our results. Okay, so there we have human fieldwork. Now let's go over to the physical fieldwork. And if you're still with me, you're doing fantastic. Let's keep going. So, how does the river channel cross profile of the Cardi Mill River Valley change over distance? So what we're saying is, how does the width and depth of Cardi Mill change as you go downstream? Alright? And our hypothesis was that the river gets wider and deeper as you go downstream. So as you move from Lightspout Waterfall, when we hiked up to the top of the valley, we expect it to be narrow and shallow. Whereas as we go further downstream, we expect it to be wider, can't really show you on this little picture, and deeper. Because of fluvial processes, which just means river processes, vertical erosion, down, deeper, lateral erosion via hydraulic action, side wider. So why did we choose this location? So as with human, the footpaths are well maintained by the National Trust. This means the risk is low. You've got somewhere safe to walk. The river, we needed a river to measure, so you've got to have a river, all right? You can't completely get rid of all risk. But the river was shallow, and this means that the risk was low. The river has also got a very weak current, so you're unlikely to get swept away. Lower risk. And again, you could memorise this quote, there was enough variation downstream to show change. So the river distances, we tried to go about 1,000 metres in between each one. There was enough distance there to show change. Now, the relevant geographical theory is the Bradshaw model. So you will have seen this in class. Basically, Bradshaw, as long as we're saying that pebbles get smaller and rounder downstream, he said that the river will get wider, the river will get deeper. Okay? Other secondary data that we could refer to are historic photographs of the area to show what the river channel looks like, and also previous studies. So we could get the data from kids who've done this in the past, or scientists or geographers who've done this in the past, and compare it. So that's our secondary data. Anyway, primary data method number 1, what we did. So we got ranging poles, those big red and white poles, and we put them at either side of the river channel. Okay? We then got a tape measure, pulled the tape measure across the river, pulled it taut, and we measured the width. All right, and we recorded that on our recording sheets. Why did we do it? All right, remember, we ain't got millions of pounds to do this. We're at secondary school in Albury. But the method was simple but effective, and it would allow us to test the geographic theory, the Bradshaw model, effectively and provide us with accurate data. In your head, keep remembering, excuse me, that we're trying to fill up the aims of the investigation, which is simply answering that question. Sampling method. Again, we use systematic sampling at 3 points of equal distance downstream. And this was to give us accurate data that reduces the risk of bias. All right? Somebody might have thought, man, it looks easy to measure it there. Let's just measure it there and go and eat our lunch. We want to get rid of that. Links to hypotheses. Well, systematic width sampling was a simple but effective method. It would provide us with accurate results that allow us to test the Bradshaw model theory, as mentioned above. What was the other primary data? Remember, we want to look just at the width, but also the depth. So we used measuring river depth across the channel. How was it done? So we got the width of the river channel and we divided that by 10. So we had to do this second. It wouldn't have worked otherwise because we wouldn't know the width. Then, at every 10th of the river, we got a meter ruler, held it in the water and recorded it. Now, funnily enough, where I'm sitting, there is a meter ruler here, so something like this. So we held it in the water. We should have held it thin ways so the water doesn't splash up, and we recorded the depth. Why? We did this because the method was simple and effective, and it would allow us to test the geographic theory effectively, and it would provide us with accurate data. So it was a reliable method to provide us with accurate data. Sampling. We used systematic sampling at 10 points across the channel to give us accurate depth data across the channel. All right? And this reduces the risk of bias, but it also, because we got 10 pieces of data, allows us to use an average or a central tendency measure called the mean. So we could add up all the depths, divide by 10 and get the mean depth, and that's good for interpretation. Links to hypotheses. Well, again, it's systematic depth sampling. It was a safe and effective method that would provide accurate results to allow us to test the Bradshaw model theory. Okay, so there are our two primary methods. Let's have a look at, let me move down the bottom. Let's have a look at presentation. So again, could be a 6 marker. It could be a 6 marker for human or physical. We did similar techniques, but they are different because the data is different. So we use located line graphs to show the river channel cross sections. So for each site that we measured the width and depth, we drew a line graph, okay, that showed the shape of the river channel. Once we got our graphs, we then stuck them on the base map, like that OS map I showed you earlier of Cardiff Mill Valley. Now the x-axis showed the width accurately in centimetres, whereas the y-axis showed the depth accurately in centimetres. Now this would have two y-axis to make it easier to read, okay, because you are doing a cross section. And because the data is continuous, that's why a line graph is appropriate. All right. Now we use centimeters on the y-axis because the river was never more than 12 centimeters deep, so it was appropriate. Okay. I put x-axis there, but I meant y-axis. But again, you could use it. You could say we used meters on the x-axis because of that. Now, the located line graphs were visually clear and allowed us to spot patterns and anomalies at all the river sites we visited to take measurements. Okay? So if you looked at those line graphs, you could very quickly say, oh, it's very deep there. Is that an anomaly, or is that an issue with the reliability of the method? Or, hang on, that looks really shallow there. I expected it to be deeper. And you can quickly spot these patterns. Okay? So, we presented our data. We need to interpret it. What does the data show? So it showed. The data showed that both the river depth and width increased downstream. So the river got wider and deeper generally. There were some anomalies. However, we used measures of central tendency such as the mean to ensure that any outliers, any data that lies outside of the normal data, removed from the overall data. So again, we're using mean, the mean average, to help us with our interpretation. Conclusion. So, in conclusion, the river width and depth increased over distance, other than the odd anomaly. So I think at site 2, there was one part of the river that was massively deeper than anywhere else, but we think that was an anomaly. Okay? Now, this conclusion is valid to a large extent because of the reliability of the methods and the accuracy of the results. Once we did the mean test on site 2, it did fit the pattern once we did the mean measure of central tendency. Okay, right, final bit. Moving my face over there because we're going to look at the evaluation. So again, we're looking at evaluation. Can we trust our conclusions? Are they valid? Well, that depends on how accurate the results are. How accurate the results are links to how reliable the methods are. So, measuring the river width. This was a great method, but some kids didn't pull the tape taut. So rather than measuring the width, they were measuring the width plus the dip of the tape. Okay, so that wasn't very reliable. And the results would have been less accurate because we're not measuring the exact width of the river. This problem with reliability would have increased our width measurements, meaning the results are less accurate. Alright? This had an impact on the validity of conclusions to a small extent. I don't think it made that much difference. I mean, nobody, from what I can recall, let the tape measure drag in the water, because rather than being 4 metres wide, it would have been about 30 metres wide or something daft, and the tape measure would have probably exploded. But although there was these problems, I still think that we can trust our conclusions and they're valid. Now, solutions to this was, 1, hold the tape and get 2 students to double check the measurements. Humans make errors. Make sure the tape's taut, get another student checking the measurement on the tape, agree, write it down. Another more high-tech option is you can have like laser range finders. They use them in the building trade, and you could point the laser at one side of the river to the other and it will tell you how far it is. But I think for a secondary school on a low budget, we just need to stick to simple and appropriate methods. Right, measuring the river depth across the channel. So, problems. I think this was reliable, but some students didn't hold the ruler slim to the current. So if you imagine the water's going down there, some kids were holding it like that. So the water would end up going up the ruler. It would be coming from this way, it would be going up. So rather than measuring the depth, we were measuring the depth plus a bit of splashback. Alright? Other things, large boulders on the bottom of the riverbed. Some kids were putting the ruler on top of them. You're not measuring the depth of the river then, are you? You're measuring the depth of the river minus however big the boulder is, or the rock, whatever you want to call it. Now, holding the ruler flat against the current meant the water splashed up, creating higher depth readings that were inaccurate. Measuring the depth on top of rocks would have given shallower depth measurements. So that's what I've just told you. So that was the impact on the accuracy of results. What about validity, trustworthiness of conclusions? So this had an impact on the validity of conclusions to a small extent. However, I still believe that we can trust the validity of our conclusions. I think the conclusions were pretty valid. It did get wider and deeper generally, other than the odd anomaly. I know some of the results were not as accurate as they could be, but generally the methods were sound and reliable. If we did want to improve this, quite simple really, ensure you hold the ruler slim against the current to avoid any splashback, and avoid large bricks and builders when measuring depth. Other things that you could do, I'm going to put down my massive ruler now before I have my eye out. Other things that you could do, repeat this again at a different type of year. If there's been heavy precipitation the week before, the river discharge is going to be higher. Or if it's not rained for a month, which might happen in the summertime, there might not be hardly any water. Go and visit another. We went up Lightspout Hollow. There's a river valley up the road called Ashes Hollow. Could we use that to test the theory? Alright? Do more sampling at each site rather than just do one. Maybe move a metre forward and a metre back and do width and depth measurements there. But we got limited time. Alright, so that is the end of the video. Hopefully I've gone through everything to a decent standard. Now you can revise for those 20 odd marks, 23 marks was it? In the comfort of your own home. Respect.